All right. Okay, applications of systems of linear equations in case you missed it. So when solving real life situations, remember you can always solve them multiple different ways using a table, guess and check methods. We can graph them, although in real life sometimes the numbers in graphing get rather large. And then writing two equations and then solving with substitution or elimination. This is what we're going to focus on in this lesson because this goes along with what we've been learning. The three types of situations we're going to look at are how much of each type, comparing two things, and distance versus rate. So, problem 1. You sold 2 different types of wrapping paper for your band fundraiser. One type sold for $6 a roll, and the other sold for $8 a roll. You collected a total of $92 for the 14 rolls you sold. How many of each type were sold? So this is a how much of each type problem, because it's asking us how many of each type did we sell. So let's first define our variables. We'll let X be, we'll call it type A. Type A is our $6 roll. And we have Y is type B, that's our $8 roll. So in this problem, we're going to have 2 equations. First, we have a total equation because it tells me that I sold a total of 14 rolls. So for the total, type A plus type B, all together I sold 14 rolls. Then I have a money equation. Because the rest of the information that I'm given is I sold one for $6, the other for $8, and I collected a total of $92. So that's going to look like this. I got $6 per roll type A, $8 per type B roll, and I made a total of $92. So now I have it set up nice. And from here you can either use substitution or elimination to solve. I like to use elimination personally. So if I'm going to use elimination, I'm going to look to eliminate maybe my x variable. So I'm going to take the top equation then times -6. So that I have opposites. I have a 6x here, so I'm going to need a -6x in this one. So multiplying each thing here by -6x, -6y, and 14 times 6 at 24 to 84, -84. Keeping my bottom equation the same. All right, and then in elimination, once I have opposites, I can add those together. So now my x's are eliminated. -6y plus 8y is 2y. -84 plus 92 is 8. Divide both sides by 2. Y equals 4. And remember, I sold a total of 14. So if I sold 4 $8 rolls, that means that I had to sell 10 $6 rolls. So then, just to finish it up, I would write some sort of sentence. So I sold 4 $8 rolls and 10 $6 rolls. How many of each type were sold? Okay, this is another how much of each type. Very similar. Katie has 70 coins. She has nickels and quarters in her piggy bank, and their total money is $13.90. How much of each coin does she have? So again, I'm looking for how much of each type. This time I'm looking for how many nickels and how many quarters. So I'm just going to use N for nickels and Q for quarters. So I have a total equation again, and I have total number of nickels plus quarters, 70 coins. So N plus Q equals 70. Then similarly, I'm going to have a money equation, except for this problem doesn't tell me, like the last one told me I had $6 rolls and $8 rolls. This one doesn't tell me how much a nickel or quarter is worth because you should know that. So a nickel is 5 cents. That's going to look like this, 0.05. And a quarter is 25 cents, so that's 0.25 Q. And altogether I have $13.90. So $13.90. Okay, so here's my setup. Elimination is a great choice, again, to solve this. So let's say I want to eliminate my ends. So since I have a positive 5/100ths here, I'm going to need a negative 5/100ths up here. So I'm going to take the first equation by negative 5/100ths, or by negative 0.05, and multiply that whole first equation. Whoops. Multiply that whole first equation by negative 0.05. So that's going to be negative 0.05 N minus 0.05 Q equals, and 70 times 5 will be 350. So move the decimal, be negative 350. Keep the other equation the same. Q equals 1390. Now I have opposites, so my nickels, my ends will be eliminated. Adding these two together, negative 0.05 Q plus 0.25 Q, so 25 cents minus 5 cents, there's 20 cents there. Negative 350 plus 1390 will be positive 1040. Divide that by 0.20 on both sides. That means quarter, since 1040 divided by 2 is 520, so there's 52 quarters. Going back up to my original problem, I had 70 coins. So if I have 52 quarters plus how many nickels equals 72, or 70 total. So that means I must have 18 nickels because I have to add up to 70. So final answer, 18. Oh, this pen is not working very well. 18 nickels and 52 quarters. 18 nickels. All right. All right, this is a different type of problem. It's comparing two things. So this is when you're comparing the price of two companies or so forth. So you have the choice between two different internet service companies. Cable One is $12 per month and $2 per hour, and Mid-Continent is $27 per month and then 50 cents per hour after that. So how many hours would you need to use the internet per month for the service to be the same price? So Cable One charges a $12 fee and then $2 per hour on top of that. Mid-Continent is like a $27 fee and then 50 cents per hour after that. So my variables are, X is going to be my number of hours, and my Y is going to be my total cost of this plan. So we'll do, and then for comparing two things, I'm going to have two separate equations for each company. I'm going to have an equation for Cable One. Cable One's cost equals $12 per month, so that's a flat fee, plus they charge $2 for each additional hour that you're on the internet, so $2 for each hour. For Midco, their cost is $27 per month, but then they only charge 50 cents per each additional hour. And the question says, how many hours until they are the same price? So when are they equal? When are the costs equal? Since I want to know when these two are equal, I want to set them equal to each other. You could also think of it as using substitution. So y equals 12 plus 2x, and I want to know when are these two costs the same. So I'm going to substitute the 12 plus 2x into the equation for this cost. So setting them equal to each other and solving for x for hours. When I have variables on both sides, I'll need to bring my x's to one side of the equation. So I'm going to start by subtracting 0.5x from both sides. You get 12. 2 minus 50 cents is $1.50 equals 27. Positive 12, so I'm going to subtract 12 from both sides. $1.50 x equals 15. Divide by 15. Divide by 1.5. 15 divided by 1.5 is going to be 10. So when are they equal? Well, when x equals 10. What does that mean? After 10 hours. So the costs are the same at 10 hours. So the cost is equal at 10 hours. Now, since at anything over 10 hours, cable 1 is going to be much more expensive because every hour after that 10, it's going to be $2 more per hour versus 50 cents per hour. So 10 is kind of our breaking point. At 10 hours, cable 1 and Midco both cost the same. You could get that cost by substituting that 10 back in. 12 plus 2 times 10, it's going to be $32 for those 10 hours. Now, after 10 hours, I'd say go with Midco because it's only going to be 50 cents per hour after that. So anything less than 10 hours, cable 1's the better deal because you have that low intro cost fee, only that $12. So kind of deciding between the two. But it just asked me when will the cost be equal. They'll be equal at 10 hours. If it asked me what the cost was, then I'd plug it back in and get the $32. If it asked me which company I'd want after 20 hours, I'd say Midco because it would be the cheaper option. Another comparing two things. This time we're trying to figure out which catering company to use. We have company A that's $100 plus $3 per person, and company B which charges $60 but then $5 per person. So we have X and Y again, and Y is going to be our total charge or cost of catering, total cost. And that cost depends on how many people. So X is going to be the number of people. And then we have an equation for each company again. So company A and company B. So for company A, the total cost is going to be $100 flat fee plus $3 per person. Where company B, you only pay $60 up front, but then you pay $5 per person after that. And it says, for how many people will the cost be the same? So again, we want them to know when these two are equal. So I'm going to set them equal to each other, 100, plug in this 100 plus 3x in for the second y. So essentially using substitution here. I keep clicking the button on this pen, it's not helping. Okay, now I need to solve for x. This time to avoid negatives, I'm going to start by subtracting 3x from the left and moving it over to the right. It's positive 3x, so I'm going to subtract it from both sides. That leaves me with 100 over here, and 60, and 5x minus 3x is 2x. Since I moved my x's to the right, I'll have to move my 60 to the left. So positive 60, so I will subtract 60 on both sides. And I get 40 equals 2x, divide by 2 on both sides, and I get x equals 20. And remember, x stood for number of people, so after 20 people, the cost will be the same price. So after 20 people, the cost is the same. How much does that cost? Well, I'd have to plug 20 into either one of these equations. If I plugged it in here, 100 plus 3 times 20, I'd get 100 plus 60, so 160. The cost is 160. So after 20, anything over 20 people, company A would be the better plan. For anything greater than 20, anything less than 20, you're going to want to go with company B. Greater than 20, company A, because it's only $3 per person after that 20, versus company B, you're going to pay $5 per person after 20. But less than 20, you pay a lower intro price. So less than 20, company B, more than 20, company A, 20, they're the same price, cost you 160. So again, that was comparing two things. So we have an equation for both, and we want to know when they're equal. The last examples are distance and rate problems. So it says a plane traveled 540 miles in 6 hours with a headwind, and a return trip with tailwind took 5 hours. So with a headwind, that means that they're flying with the wind, and a tailwind, or no, flying against the wind, so the wind's pushing. And a tailwind, they're going faster. It only took them 5 hours, so the wind and the plane are going the same speed, or the same direction, I mean. Find the speed of the plane and the speed of the wind. So those are my variables. That's what I'm looking for. So let's let x be the speed of the plane, and we'll let y be the speed of the wind. So we need to do a little bit of work off to the side here. First, we need to remember that when we do distance problems, distance is rate times time. Or more importantly, rate is equal to the distance divided by time. So I want to know the rate these two things are going. So I need to put the 540 miles in 6 hours into a rate. So I'm going to find my rates over here. First one I'm going to do is when the plane is traveling with the wind. So that's with the wind. It only took me 5 hours. So 540 miles in 5 hours. 540 divided by 108. 108 miles per hour. So miles divided by hour. The other rate is against the wind. So that was with the wind. Now when we're going against the wind, I went 540 miles, but it took me 6 hours. So 540 divided by 6 is 90 miles per hour. So I have my two rates here. Then here comes my equation now. So the speed of the plane plus the speed of the wind, so that's when they're working together. When it took 5 hours together, they were going 108 miles per hour. When you have the speed of the plane minus the speed of the wind, so when they're working against each other, then you're going slower. Now you're only going 90 miles per hour. So again, this is when the speed of the plane and the speed of the wind are working together. You're going faster, 108 miles per hour. It took you 5 hours. The speed of the wind, take away the speed of the speed of the plane, take away the speed of the wind that's working against you. It took you 6 hours, so you're only going 90 miles per hour. Now it's set up nicely for elimination because my y's are already opposite. So I can go ahead and add those together. X plus x is 2x. My y's are eliminated. 108 plus 90 is 198. Divide that by 2, and you get x equals 99 miles per hour. So that was how fast the speed of the plane was going, 99 miles per hour. Then to figure out the speed of the wind, well, you know that x minus y equals 90. So if x minus y equals 90, and x equals 99, then y must equal 9, because 99 minus 9 is 90. So I just used those two to plugged it back in and figured it out. So the speed of the wind was 9 miles per hour. Hold on, Mia, I have one more problem to do. Very similar again. This time we're doing 3 hours to fly 1,800 miles. In the direction of the jet stream, that means with the wind. And then against the jet stream, against the wind, took me longer, 4 hours. So here's our variables again. We have x is the speed of the plane. Yes, Mia? Those are earplugs. Y is the speed of the jet stream, or the air, or the wind. I'm going to figure out my rates. So I flew, when I went with the direction of the jet stream, so with the wind, yeah, I did 1,800 miles in 3 hours. 18 divided by 3 is 6. So it's going to be 600 miles per hour. Against the jet stream, I had an extra hour there, so 1,800 divided by 4. So 1,800 divided by 4, cut it in half, you get 900, cut it in half again, you're going to get 450 miles per hour. So when they're working together, you're going faster. So together with the jet stream, you're 600 miles per hour. When the jet stream is taking off, the speed of the planes, you're going slower, so 450. It's set up perfectly then for elimination. Add them together. X plus x is 2x. 600 plus 450 is 1050. Divide that by 2. Half of 1,000 is 500, so 525. 6, 7, 8, 9, 10, yeah, 525. So that means the speed of the plane was 525 miles per hour. And the jet stream then, if they together had to add up to 600, and I knew that the plane was going 525, then that means that the wind has to be 75 miles per hour for them to add up to 600 together. So the speed of the jet stream would be 75 miles per hour. Okay, you should have a worksheet that matches the applications of systems worksheet. And you're going to want to decide which type you have and how much of each type. You want to do the total equation and then your cost equation. Distance and rate, change it to miles per hour and set the plane speeds and the wind speeds together equal to those miles per hour. You're going to have one equation with a plus and one equation with a minus. The one with the plus will be the one that's going faster because they're working together. And then when you compare two things, you have one equation per service and then you set the two equations equal to each other. Make sure you show all your work. You can use any method if you have trouble coming up with the equations, you can do the guess and check or make the table. Just show all your work to justify it. Okay, hope that was helpful. See you later.